This is the third in a series of videos covering how to use LINX with the RPiSoC. In this video, we're going to go over analog input and output. Now, I'm going to assume that you've already gone through the setup required, which I covered in the first video, and that you're already roughly familiar with the general structure for LINX VIs, which I covered in the second video. Now, for this, we're going to need some circuitry to generate our analog input signal. I've got the schematic here. It's pretty simple, just a single potentiometer. 5 volts hooked up to one side, ground hooked up to the other, and then the wiper is going to be our analog output signal, outputting to the input of the RPiSoC. Over here you can see my physical circuit. I've got a potentiometer here. Each side is hooked up to the plus and minus on the port 3 port, and then I've got the middle pin, the wiper, going to port 3 pin 0, which is going to be analog channel 1. Now for analog output, I've got ground and port 0 pin 1 hooked up to my multimeter over here, and that's just reading voltage. So later on when we go to change the voltage, we can see that reading change. So let's get started building our VI. I'm going to minimize this, and we'll start with a blank VI. Now, as with any LINX VI, we will need to start with an initialize. So I'll bring that in. I'm going to add a control for the serial port. And then we will add our analog, go to peripherals, analog, read. We need to connect that with the LINX ref and the air bundles. And then our analog read needs a channel to read, so we'll create a control. And we want to display our output. So we're going to create an indicator. So that's it for read. Now we want an analog write. So we'll go to LINX, peripherals, analog, write. Now this one's a little tricky because right now LINX doesn't fully support getting the device configuration for analog writing. So we're going to have to do some manual configuration editing here. It's not too complicated though. First we'll start with an analog output channel control. And now LabVIEW doesn't know what the analog reference should be, so we need to override that by creating a constant here on the reference. And the default analog out reference for the RPiSoC is going to be 4.08. So we'll just have to add that. And the other thing is in this bundle, there's a setting for the analog output resolution bits that does not get set automatically. So what we're going to do is right after initialize, we're going to right click on the bundle. We're going to insert a bundle by name. We want to click on platform. You need to make sure you get the little hand. We'll change that to analog out resolution bits. Move that guy. Got to rearrange everything here. So we'll move that guy down, and we want to hard code that at 8, because the analog out device is an 8-bit device. And finally, our LINX VI needs a close. So we will attach the resource, the air, and we want this to run continuously. So we're going to add a while loop around the read and write. For our stop condition, we're going to create a button, but like we did before, we're also going to bundle that into the air bundle. So we'll create a Boolean OR gate, and it will stop if we hit the button or if there's an error. So with that, our block diagram should be good. So we're going to switch to the front panel. I'm just going to rearrange some things. I like to put the stop in the bottom right hand corner. Our analog in value can go with our analog in channel, analog out channel. Oh, and you know what we forgot? We forgot an analog out value. So we need to create a control so we can actually set what that value will be. So now we have our analog out value. and serial port that LINX will be using. Now I like to change the analog in value, go to replace, and change it with a graph, which looks cooler. So we're actually going to see a graph of our input. Now you'll want to go to Properties and go to Scales, the y-axis. We don't want to auto scale. We want to hard code this at 0 to 5 volts. So we're just going to change that and hit OK. And for the analog out value, I also like to replace that with a little slider. We'll make that a little bigger. And this, we want to set the scale to be 0 to 4.08 volts. Okay. Now, analog out channel, we wired it up to port 0 pin 1, which is analog out channel 1. Analog out channel 1. Analog in channel 1 is port 3 pin 0, which is what we wired it up to. Now we want to double check our device manager. Looks like RPiSoC, in my case, is COM3. Yours might be different, so make sure you check that. We're going to set this to COM3, and then we're going to hit run. And once you give it a few seconds to get up and running, you'll see our plot of the analog in voltage. And you can see as I rotate the potentiometer, that value changes. You get a nice little graph there. And then for analog out, if we take a look at our multimeter, and we drag this slider, you can see the voltage on the meter change with the slider. So that is how you use the analog write and read LINX VIs with the RPiSoC.